Hi everyone, welcome to the fifth part of the TicTacToe in Julia series. And in this video, we'll be looking at the idea of minimax algorithm. We won't really write any code in this video. We'll just look at how the algorithm actually works, and I'll be explaining the algorithm using this little flowchart that we have. Right? Okay. So let's get started. So the initial setup we have here is a classic tic-tac-toe board, and we're midway. We're halfway through the game. No one has won yet. No one has lost yet. It's O's turn right now in this case because O started. In our actual game, X will start, but over here O started. It doesn't really affect our, it doesn't really affect the game. It doesn't matter who starts. But if I do this chart using if X started, we would have a lot more we would have a lot more uh, outcomes to cover, and that'll be really hard to explain. So I assume that over starting here in this case, that's not how our game's going to work, but it just makes it easier to explain. We're not starting from the beginning like the empty board, because that'll be too many cases to draw and explain. But yeah, okay. So what we're going to do now is we'll look at the basic idea of minimax using this half half done game. Okay, so right now O has three choices. So for that we make three sub cases. The new move is marked in gray, while the current moves are marked in black. So as you can see, I've drawn all the three cases here. One over here, which is on the left, and then this one, and this one, right? And of course, in these below these, there are even more sub cases where now it's X's turn, so X can choose between these two spots. So it places it here, um, or it could place it here. Don't worry about the numbers and the colors and all that. Look at the outcomes. So it could place it here, in which it will win. In which case it will win. We'll get three in a row. Or it could place it here, right? Uh, or it could place it here in this case. When if we put O over here, it has two choices again, these two spots. We draw the cases for that. If we put it here, then it has two spots again. We draw those two cases for that. Now in each case, now it's O's turn. We obviously O has no choice here, he just puts it here again, same thing. uh, Now here X already won, so there's not going to be any sub case here. uh, Here again X won, so there's not going to be any sub case. And yeah, so you notice that there's no way for O to win. It can only tie or lose, right? There's two outcomes in which it loses, and four outcomes in which it ties. So we want to either tie the game or win the game. We don't want to lose. We never want to lose, right? That's what we want to do. We want to play. We want to play as good as possible, right? We always want to win or tie. So if you notice in our little check win function that we wrote in our code, we are returning player 2 win, player 1 win, or tie, or nothing. Nothing basically means that the game is still going on. We won't. That's not really a terminal case. So yeah. Now player 1 win is -1, which means that if X wins, it's -1. If it's a tie, it's 0 or it's +1, right? So now let's just mark that here, right? -1 for X winning, 0 for a tie, 0 for a tie, -1 for X winning, 0 for a tie, 0 for a tie again. So now we want to avoid these cases in which X is winning, right? So I put these little boxes over here for desirable outcome, undesirable outcome, and neutral outcome. So there's only undesirable and neutral outcomes here in this case. There's no way where X can actually win. I mean, sorry, O can actually win. So we don't really have any green boxes here, right? So I drew the terminal points with in boxes, right? So you can actually uh, so it basically shows that the game ends there. Uh, yeah. So this is our board, right? I mean, these are all the cases that we have. Uh, so we wrote down all our scores, right? It's a recursive algorithm, so it's going to return some value which its caller will get. So this zero will just ripple back up. The zero will ripple back up. Zero will ripple back up. This zero will ripple back up. Now, this is because there was no other choice, right? Now we have a choice here. Look at this, -1 or 0. Which one to choose, right? So, and again here, 0 or -1. Here is 0 or 0. There's no choice, but whatever. Okay. So now we want to add this idea of a choice, right? And now here we define two terms, minimizing player and maximizing player. Maximizing player is one that wants to maximize the score, and a minimizing player, you guessed it, it's one that wants to minimize the score. And now these zeros and ones and -1s are what we call the score, right? So look at this. If we want to, so we have three outcomes, right? If um, we obviously the maximizing player obviously wants to maximize the score, right? So that'll be +1. Uh, so it wants to maximize the score, in which case it will win, right? And the minimizing player wants to minimize the score, in which case it will win, right? It gets -1. So that's we've drawn these. So we made these two lines for minimizing player and maximizing player, uh, and this actually depends on the whose turn it is. So at the start, it's the maximizing player's turn, which is our O. We want O to win. We want to maximize the chances for O to win. So we call that our maximizing player, and the X will be the minimizing player because it wants to minimize the score. Okay, so it's a maximizing player's turn, so that's why we do the green lines, and the minimizing player we have these red lines. So, uh, so now let's look at this, right? Now it's over here. Right? Look at this piece here. Look at this piece. Um, Over here, we have two choices, -1 or 0, and it's the minimizing player's chance. So the minimizing player obviously wants to minimize the score. So it'll go with -1 here. In this case, it'll go with -1 again. And in this case, it doesn't really have any choice. So it just ripple back to 0. So we saw that. So it takes a -1 as minimum and it puts it back there, right? It takes the -1 because that's the minimum, puts it there. Now let's zoom out a little bit, right? So now we got our, so the minimizing player is done playing, and now it's our maximizing player's turn, right? Turn to check for the best outcome, right? So look at our choices here. We have -1, we have -1, or we have 0. We want to maximize it, so we'll pick up 0. And look at that. We have avoided all the cases in which X is winning. We have successfully made an intelligent algorithm that can predict, that can look at all the cases of a game and just go, that is not what I want. I want this, right? And it's gonna go pick up these cases. Okay, so that was the basic idea of Minimax. I'll include this little graphic in the description. I'll link it in the description. We didn't write any code, so the code currently will just be the same as the code from the last video. As always, the final product, the final code that we will have at the end of the series is also linked in the description. We'll write some code for Minimax in the next episode, the next part. And thank you for watching, and I'll see you in the next video.